Section 3.2, and we're looking at finding probabilities for normal distributions. Now, what I suggest is if you haven't thoroughly done exercise 3A in section 3.1, go back and have a look at those. By the time you get to this, the hard work should be over, okay? If we can picture the normal distribution, if we feel the shape of it in the right sort of way, this shouldn't be a huge stretch here, okay? So let's have a look. In the example that they give us in the textbook, we have a normal distribution, a random variable, which is distributed with the normal distribution, with a mean of 30, a standard deviation of 4, okay? So we should immediately be picturing this. This is why I say go back to section 10.1 if this doesn't feel intuitive. As soon as you see that, your head thinks to yourself this, okay, right, I've got a bell-shaped curve, I've got this asymptote either end, I've got a 30 in the middle, and I've got a standard deviation of 4. So roughly speaking, about there is 34, about there is 26, 2 standard deviations away is about here, right? So only 2.5% here, 2.5% here, 38 there, and 22 here, okay? So if you're not sure where I got the 2.5% from, or if you're not sure where I put the lines here, roughly on the point where the curve seems to sort of turn around a bit, then go back and get familiar with section 10.1. We are thinking 2/3 of the data in here, 95% of the data between here and here, and we're picturing that already, okay? Now the question that we're being asked is what's the probability that this random variable x takes a value less than 33? So we need to translate that into our heads. We need to translate that in our heads into the following thing. Here is 33. Okay, there it is. What's the probability that we get a value less than 33? So that is, what is this area here? What's the area that I've shaded in there? Okay. Now, you should know that the area up to 30, that area there, is 0.5. You should know that the area between 30 and 34 is 34%, or so 0.34. So less than 34 should be 84%. So this value here is we're expecting a bit less than 84, right? 84% take away this bit between 33 and 34. So that's what we're expecting. The reason that's important is because the way that you're going to solve this almost all the time now is using your calculator. And if you're going to put something in your calculator, it's a good idea to have a rough idea what number should be coming out of the calculator. Otherwise, it just disappears into the calculator, pops out of the calculator. If you type something in wrong, how will you ever check? Okay? So the answer we're looking for is a bit less than 0.84. Now, before we get into the calculator, let's just have a think about this y, okay? Now, I said in the last section, this thing is a curve, right? So strictly speaking, there is a y-axis up here. We never bother drawing it in. And strictly speaking, that y-axis has probability density on it, okay? So we could have y in terms of x, if this is our x-axis, and we could do an integral, right? We could evaluate the integral from minus infinity up to 33 of whatever this function is. And that is doable. It's just not doable at A level, right? The function you've got to integrate is a nasty, stinking one. If you're interested to see what it looks like, Google normal distribution, you'll find it. I'm sure it'll be on the Wikipedia page. The integration is difficult, and then substituting in those things is a pain. So traditionally, what happens is we have tables like this. Now, you don't need to use this table particularly. I think it's helpful if you're aware of these tables and you get provided with them in the exams, okay? But traditionally, we get tables that look like this. Is the old version of the Excel textbooks. It would look like this, right? Here is our normal distribution, and this one is called Z, and if you've looked at normal distribution, you know that I'm fibbing slightly here. This Z is slightly different to a capital X, but it's the same sort of idea. So this is our normal distribution, and in this case, it happens to have mu of 0 and a standard deviation of 1. So we look through, what's the probability of Z being, Z, the normal distribution, taking a value less than or equal to Z, the little value. So if I was interested, what's the probability of being less than or equal to 0.3, I would look down this column here, and I'd have 0.3, I've gone past it, haven't I there, 0.3, and the area to the left of that 0.3 is 0.6179, okay? So I just look it up in a table. So you can imagine In fact, this wasn't quite the way it was, but you can imagine you have a great big book of tables, you look up mean equals 30 and standard deviation equals 4. You look down the row that says, well, when that value there is 33, this value here takes the value of, and then you look the number up. Now, these days we don't have to do the integral. We don't have to get a big book of tables and work it out that way. What we can do, though, is just use a calculator. Now, I'm not in the business at the moment of doing sort of how to use the calculator videos, because everybody's got different calculators. I have an intention to go through the most common things in separate videos. So you may well find in the playlist that the next video is a calculator video, just a minute-long one showing you where to find things. But look on your calculator, you're looking for the normal cumulative distribution function. So look in the manual or Google the instructions. You're looking for the normal cumulative distribution. You'll need to tell the calculator mean. You'll need to tell the calculator standard deviation. So you'll tell it it's a normal distribution with a mean of 30, standard deviation of 4. We're interested in the probability of being less than or equal to 33. I think some calculators want to know left-hand tail or right-hand tail, and we're looking for the left-hand tail. In a lot of calculators, you have to put in the lower limit, and in this case, the lower limit is minus infinity, right? I want all the area to the left of 33. So just put in what is going to be practically minus infinity. In this case, the mean is 33, the standard deviation is 4, 3 standard deviations away is basically all the data. So if we went down to 20, the difference from 20 up to 33 would probably get a good answer. But let's just go even further than that. Let's go from 0 up to 33. Or what some of my students do is just put a lower value of minus 1,000. It's not going to matter. Just put a very, very low value that you know is far enough away. How far is very, very low? Well, a big chunk more than 3 standard deviations will do the job. Okay? So that's the idea there. But can you see the important thing is just picturing this, draw the curve, work out this is the shaded area that we need, and then stick it all in the calculator. Let's have a look at the next example. Probability that this same distribution takes a value bigger than or equal to 24. Okay, so I know that this distribution has a mean on 30. 24 is going to be a bit more than 1 standard deviation away, and it's this area that I'm looking for. Okay, so that area that I'm looking for, I know is going to be a bit more than 84%, or a bit more than 0.84. Now, how do I find it? Well, you could think of it, and now this is where it depends what sort of calculator you've got, and you're going to need to go and look at the instructions. If you've got a bit of an old-fashioned calculator or one that's difficult to move around, you might want to stick with always looking at the left-hand tail and always being less than. So if I worked out this area here, I could work out the probability that x is less than 24. And once I know that, I've got this area here. So if I do 1 minus that, I would have this area up here. Okay? More likely, you're going to have a calculator that's going to ask you whether you want the right-hand tail or the right-hand tail or the left-hand tail or some equivalent of that. What you want is this area here. Think about the way the numbers go in your personal calculator, and you just enter mean is 30, sigma is 4. We want to know the probability of getting more than or equal to 24, so your little x value is maybe how they ask you to put it in. Your little x value is 24, and you want the right-hand side of that in the normal cumulative distribution function. Okay, I'll plough on through the examples that they've given us just to make sure I've covered all eventualities, but I thought that by this point most people are happy with this video and are turning it off to go and play with exercise 3b. But let's have a look. If we are asked for something like the probability of taking a value between 33.5 and 38.2, well, the way to think about that is, again, picture the thing, do a little sketch of it. There's 30, there's 33.5, there's 38.2. If you have one of those calculators that asks you for the lower point and the upper point, you just put those 2 points in and it'll find the area in between. If you've got a different style of calculator, again, perhaps an older one, which isn't as sophisticated, you could do the area up to 38.2. 38.2. Then you could do the area up to 33.5, and that would be that area there. And then you take away this area, take away this area, would find you the area in between. Okay. Now, it might just be that I'm old-fashioned and I learned this without a graphic calculator when I first learned it. I like these diagrams. I think they tell you what you're trying to find out. I think they give you a chance of estimating the number that's going to pop out of the calculator and therefore spotting if you made a mistake. And I think they give you an understanding of what the normal distribution is doing that you can use later on in the chapter. I suspect that the first time round, when a lot of people do exercise 3b, what happens is you learn which buttons to press on your calculator, you just tweak those numbers, and exercise 3b doesn't take very long, and you plow on into section 3.3. If that's the case, then so be it, but my strong recommendation is just to get a picture in your head of the normal distribution and which part of it you're looking at for each of the questions that you're doing. The best thing I would have said would be make a quick sketch of what you're looking at least this part of the sketch here, where you know you're looking for this area here, between 33.5 and 38.2 is there, okay? Example 3b, again, you may well have read through this and be halfway through exercise 3b already, but since I can take as long as I want and you're not obliged to keep watching, let's just have a look at example 3, because this is a trick they're very keen on pulling. They set up the first part of the problem. So here we've got an IQ test with 100 adults. We've got an IQ test on a population of adults, and it's normally distributed with this distribution. Mean is 100, standard deviation is 15. Adults that score more than 140 are classified as genius, so find the probability that an adult chosen at random gives a genius classification. So that's just what's the probability of somebody chosen at random getting more than 140, which is, as you'd expect, a very small probability, because 140 is getting on the way to 3 standard deviations away, isn't it? Okay, 2 standard deviations away is 130. Sorry, away from the mean, that is. 3 standard deviations, 145. So we're expecting quite a small number, and indeed we get quite a small number. Okay. Now, 20 adults take the test, find the probability that 2 or more are classified as genius. So what we're doing here is we've worked out a probability from a normal distribution. If I take an adult at random, the probability of them being a genius is this number here. What if I then take 20 adults at random? Think about this. I've got 20 people, I take them at random, and I ask the question, are you a genius or not? That is a binary question. There is a yes or no. So it's a binomial distribution. I do 20 trials and ask the question, genius or not. Success we're counting as genius, not success we're counting as not a genius. So the probability of success is this. So Y is the number of adults who classify as a genius out of 20. Y is distributed with a binomial distribution. N is 20. P is this number here. And now this is not a normal distribution question anymore. This is a binomial question. But imagine you came across that in an exam. A lot of students would start off with a normal distribution, and by part B hadn't thought that actually we can use a normal distribution to give us a number. We then run that normal distribution sort of as one trial of the binomial distribution. Okay, so watch out for that trick. It happens a lot. Hopefully you won't trip over that in an exam, because by the time you hit an exam you are prepared enough. You've seen that so many times that you're not falling for that trick anymore. Good luck with that exercise.